Hi everyone, I need to make a little follow-up video on my parameter smoothing video because there were just some things that were a little bit incomplete there and some things that might have been confusing, and I also have I received an update about how it should be done in a vibrant discussion on Discord after I made a poll in which I asked you all what your favorite types of parameter smoothing are, and it appears that I actually didn't think of all of the types that are possible, and I want to show you what I mean by that now. You can already see I added a new parameter to the interface, so that's already hinting that there was something added, and I will update this to my repository as well so that you can have it. And of course this video will be about describing what's going on there. So let me start with the assumption that from all of these smoothing types, the only ones that sound really good are linear and low pass. With linear meaning something like you have a very specific value for the time, like here 60 milliseconds. And oh, I just saw that this actually, the unit has shifted around. Lol. Okay. That looks better. Now so, and for the low pass filter it's the same. It's a low pass filter that goes 70 milliseconds or whatever I put here. And the other two smoothing types, they don't consider the smoothing length parameter because they're just smoothing over one block or no smoothing at all, which means no change. Now I added this second knob where I have some of these options as well. Obviously I don't have the block option again because I cannot use block processing again after I have already blocked the parameter. But I still have linear and the two low pass filters. So now let's start by just assuming that we have a low pass filter based parameter smoother and that we want to adjust the smoothing so that it's fast enough to be very useful for fast modulation, but not too fast, because then it will impose its own frequency. So now you heard that frequency and you might be wondering what kind of frequency is that? Why does it come? The reason why a frequency appears when you are smoothing too fast, especially with low pass filters, is because low pass filters always have such a shape, even more so, more like this, where most of it is round, but there is always this starting point where it's not very round. So you want to avoid having starting points like that. And what you can do there is to just have multiple filters in series. Then it will look more like this, where that starting point is a little bit smoother. It's still quite an edge, but it's smoother, and that's why having multiple filters in series sounds a little bit better. But then you have multiple filters in series, of course, that uses more CPU, and yeah, it can also like make things a little bit sloppier in general. So you might not want to have multiple filters in series. Now there are also other types of modulation. You don't always have these brick wall types modulations. Sometimes you just have a straight line. And let's just say that this is a very fast modulation. So then you have the individual blocks, and for each block you try to go to the last value, and would look something like this if the smoothing is very fast. So you always have these edges here in between the smoothing steps. But if there was sample accurate modulation, so if there were just way more points where we are gathering the information, then it would have a density that makes it less apparent that there are these little starting points everywhere. It would result in a way more round shape that actually enables us to have this very fast modulation without sounding bad. At the moment, considering that there are just these points, the only thing you can do to make it sound good is to actually have slower modulation, so that these points just look a little bit less edgy. But that's kind of frustrating, because you know that with the given DSP architecture that you have, you could potentially have a faster modulation that still sounds good, but the only reason why you can't have it is because the host doesn't give the plugin the parameter values sampled accurately, or even in regular steps, but just in the way that the blocks distribute them. And that's obviously not a VST3 limitation, but just one of the Juice framework. But when almost every developer uses the Juice framework, then it can safely be said that this is a general problem. And since that is not addressed by the Juice team, because they want to ensure backwards compatibility with the VST2 standard, that is not a standard anymore, we have to deal with that. And I believe the assumption of my last video was that the only way to deal with that is by choosing a specific parameter smoothing type that is hopefully working for most types of modulation shapes, especially the ones that are not so fast. But I was wrong, and I was told that there is a better way, and it actually works really, really well. It works like this. The first smoother that you have is actually block-based, and you might be saying, what? Block-based? That means that it's different for each block size. It doesn't sound the same in all hosts, and it also doesn't sound the same. What's going on there? Had to close the window. And it also, where was I? And it also doesn't sound the same with different settings of your audio interface. So it's ultimately bad, right? But it's not, because all that this means is that it already ensures the fastest speed imaginable. And if that is just way too fast, that doesn't matter. It's just making sure that the parameter smoothing is as fast as possible with a given block size. And then you put on top of that whatever else smoothing type you want, like linear, low pass 1 or low pass 2, doesn't matter. I mean, let's just choose low pass 1 and go as deep as we can with the smoothing length, and listen to how it sounds. And you can hear that it sounds pretty much perfect. We could try the other low pass filter where we have 2 low pass filters, but it wouldn't even make a difference. Now let's compare just having the low pass filter with no block processing first. And now let's try the same, not with the low pass filter, but with the linear smoother. Now I can definitely hear a little bit of a sound degradation with the linear smoother, but even that sounds way better when block based smoothing was put before. Now let's try to find a length where the linear smoothing actually sounds good with the block before. Okay, I can really not find a value where it sounds good. It might even be that I still have a mistake in that audio code. I hope not, because that would make my last video and this video as well, not very scientific. But if I find a mistake there, then I will update the video again with a third video. But the thing is, no matter if you choose a linear smoothing or low pass filtering, you should probably put just a block based smoothing before each of these to ensure maximum smoothness on very fast speeds. And yeah, that is just the thing that I wanted to add that was not in the last video. So if you come across my poll and decide if you like linear or low pass better, then yeah, that would be very interesting to me. But I think at this point I should, if I was able to throw out the block-based option, then I would do that, because now I'm just assuming that it's objectively clear that block-based smoothing needs to be there as the first step, and the only thing that really matters is what comes after it, and that is still subjective. So yeah, we can discuss that and go on with our parameter smoothing experiments from here.